what about this guy? I think this is even a homework problem. So what should I do first?
The substitution.
Yeah. So I'm going to try to make my u look a little bit bolder so that I don't have to use a different variable when I'm doing the integration by parts later. But u equals, in this case, x squared. So d bold u is equal to 2x dx. So d bold u over 2x is equal to dx. So now that means that we get to rewrite this beast as the integral. Sorry, color coding is very important to me for some reason. The integral, I'll leave that x cubed there for now, but the e is going to be to the u now. That x squared becomes a u. And then that dx becomes du over 2x. And so this x is going to cancel out with one of the x's in x cubed to make it x squared. And I'm just going to simplify a little bit. I'll pull that 1/2 out front. And now that x squared is exactly u. Times e to the u du. Okay. But now, integrating this is an integration by parts problem. And I just put those little toppers on the u there, so it's very clear that the two u's are different. But which one of these pieces am I going to want to differentiate, and which one am I going to want to integrate? I'm capable of differentiating u. I'm capable of integrating u. I'm capable of differentiating EU, and I'm capable of integrating EU. So that's not going to help me. But when I differentiate u, things get easier, right? The derivative of u is just 1. So that's a little bit easier. So I'm going to pick u to be my u. That's not confusing at all. And that means that my dv is going to be e to the u. So the antiderivative of e to the u du is just e to the u. And now that I'm done with that thought, did you guys resolve what you were chatting about, or?
Sorry, I just, it's dumb, but when you have the 2x there, and you're like taking it out of the x to the third, x cubed, how do you get rid of x cubed with just x?
So I have x cubed over x, right?
Yes.
And so that's x times x times x divided by x.
Yes.
So one of the x's cancels out, but I have two x's remaining, or x squared remaining. Now, so that's where I am on that top line, but then I look back at what I let u equal initially, and I let u equal x squared. So now that I have an x squared, I replace that with u. You're right, there's a step that I didn't explicitly state. Okay, so now I want to get all of this to fit on a line, so I'm going to use the power of technology to shrink this. Put it over there. Yay! Now this is equal to 1/2, and that 1/2 is multiplied by everything. So be a little bit careful there. But now I'm doing integration by parts, so that integral of u times e to the u, that's equal to uv minus v du, right? That's the integration by parts bit. So this is u times v, and u is just u. That's not confusing at all. Minus v du, the integral of v du. Okay, but now I can take that antiderivative the antiderivative of e to the u is just e to the u. And then I'm just going to throw the arbitrary constant out at the end because I can. So now all of my integrating is done, but I need to sub back in for what u is. So this is 1/2. Remember that u is equal to x squared, so x squared e to the x squared minus e to the x squared plus c. All right, now I'm done. How is that? You hate this. Everybody hates this. Yes?
Why do you do the 1/2 in the first place?
Because when I have the du equals 2x dx, and I solve for dx, dx is equal to du over 2x. So the x's cancel, but then I pulled that 2 in the denominator out front. Yeah. And then the trickiest bit is to make sure that that 1/2 is being multiplied by everything. The uv and then also the minus the integral of v du.
Why did it be multiplied by everything?
Because it's being multiplied by the entire integral of u e to the u. And so it's got to be multiplied by the entire integration by parts thing because we have an equality there. Yeah. So if you think of that integrand as becoming a big parenthesis, that might help you. And then the du at the end is the other parenthesis. All right?